This is lesson 42, VHDL example 24. And in this example we'll design an 8-to-3 encoder using logic equations. You remember from the last lesson that this is the truth table for an 8-to-3 encoder, and these were the logic equations that we derived. So it's straightforward to just write a VHDL program for this. The only problem is we're going to have a valid output. Remember, only one of these inputs needs to be 1. If they're all zeros, then we'll get a 0 output, but it won't be valid because a 0 output means that x0 is 1. So our inputs are the 8 x's, 7 down to 0. The outputs are the 3 y's, 2 down to 0, and then we'll have a valid output. So in the process, we'll define a variable called valid variable. The 3 logic equations we can just write in the normal way, but then we'll set valid variable equal to 0, and then we need to check to see if any of the inputs are 1. If any of the inputs are 1, then it's valid. It's only when they're all 0 that it's not valid. So we can do this by making a for loop for I in 7 down to 0 loop. Valid variable equals valid variable ORed with xi. So the first time through the loop we'll OR it with, in this case, x7, then x6, x5, all the way down to x0. If any of them are 1, then valid variable will be 1. Notice that we must use a variable here, and remember that variables get evaluated immediately using this equal assignment. So valid variable will be 1 if any of the inputs are 1, and so we'll just set the output valid to that valid variable. Here's a simulation, and we see that the input, notice we're going to use a circular 1 counter. This is one of the options you have in the simulation. It goes 1, 2, 4, 8, and so forth. So it's called a circular counter. Just one bit is 1, circulates around like that. So that's what we want for this input test. And the output, sure enough, ends up being 0 to 7. So it encodes which one is 1. In this case, valid is 1 for the entire time. Now we can make a top-level design where we'll use the switches for the inputs, the 8 inputs. You'll set one of those switches, turn it on to 1, and then the 3 rightmost LEDs should indicate which switch you turn on. We'll use the decimal point on the 7-segment displays to be the valid output. If it turns on, it means that it's not valid. So here's the architecture. The component encode 8-to-3, and then we'll have a valid signal, and then the decimal point will be set to not valid, and then when we port map this, X goes to switch, Y goes to LD, and valid goes to valid. Notice that dip switch is not valid, so when valid is 0, the decimal point is 1, and it will turn it on. So you can try this top-level design, download it to your FPGA board, and when you turn on any one of the switches, the corresponding number should show up on the rightmost LEDs.